Okay, now it's recording and transcribing. So I think we're
Great.
finally cooking with gas. Gotta love technology, which I guess we'll
Yeah,
talk about some technology today. So that's even
perfect.
better. Okay. All right. So I wanted to welcome you, Scott. This is Scott Hunnis, and he has an extensive background in automotive packaging. Um, if you could just give a little bit of your background, that would be wonderful, Scott.
Sure. Thanks, Camille. Yeah, so my background's in automotive packaging, pretty much all 15 years of it. I was a Michigan State grad and then went directly into automotive packaging as a consultant, actually. So I bounced around to many, many different companies over the course of about 5 years, and then joined Tesla for the past 7 or 8 or so. And and then now I'm back into the consulting world for the past about year and a half. So yeah, that's my background. It's been all pretty much purely automotive packaging.
Did you plan on going into automotive packaging when you were at Michigan State, or was it something that happened as you were job hunting at when you graduated?
I think it was a function of my internship actually, just sort of like led me into that because I made connections through my internship that led me to my job immediately out of school. And so uh, yeah, it was actually just kind of luck of the draw. I will say that I was definitely more, my mind was much more in the sort of distribution dynamics frame. I was much better at that than sort of like the aesthetic kind of like food, kind of packaging, so it made sense.
Yeah, that makes sense because you're dealing with the distribution and dynamics across all industries, but you're definitely focused more on it with automotive.
Yeah, that's pretty much all you care about is efficiency and optimization. Yeah.
Yes, you don't care how it looks.
Nope.
No. So, okay, I wanted one of the reasons why I wanted to have you speak to the students is because of your background with EV packaging,
Sure.
with the electric vehicles. That's something that's fairly new, and I would like to hear more about that.
Sure. Yeah, EV presents its own challenges, and I think from the battery standpoint, it'll be interesting to see where it goes. One of the unique things about Tesla was that they had I'll just say we a lot because I was recently there. Uh, so we had our own battery manufacturing, and then we also outsourced it to Panasonic. So we had actual individual cells that would arrive into the factory, and then we would assemble them into packs. It was cell, then into a module, and then the module would be built into a pack. Um, and so, sort of that distribution of the cells is kind of unique because there's like certain stipulations that have to be met from a hazmat perspective. Um, but I think where the industry will eventually be going is that everybody's just going to be developing this like in-house. Everyone's going to be building batteries in-house. It was a unique technology that automakers didn't have before, but they're building that in now. So I would say that the packaging is going to be much less like over the road. It's going to be a lot more WIP, which is work in process. So it's going to be, sort of internal to the factory.
Okay, that's good to know. So I know one of the questions that people probably want to ask would be about for the batteries. You always hear about them being sensitive to temperature.
Hmm.
Um, I work for a company that makes recreational vehicles that are some of them can get on roads like residential roads and things like
Sure.
that, but not on the highway. So we were really focused on the temperature. They couldn't get too hot, they couldn't get too cold. Can you delve a
Hmm.
little bit into that?
Yeah. We luckily with Tesla, it wasn't as big of an issue because the location of where the packs were being made were so close that it was kind of like a quick trip from even like Sparks, Nevada. It was about a 4 hour trip, so they wouldn't really get. They as soon as they're in the truck, they're going. They're coming to from Sparks, Nevada to Fremont, which is the Bay Area of California. So
Mhm.
yeah, 4 hour trip. Um, they don't get heat it up too much in that trip because they have a lot of thermal mass, and so they'd have to sit in there for days at high temp, or hours, many more hours, I would say, at high temp, to kind of reach any kind of critical state. So,
Okay. So that sounds like that was put into the design of the supply chain.
right.
Okay. Now, do
Exactly.
you know if there were any competitors that had a challenge with that because they didn't have that, say 4-hour drive or
Hmm.
something, do you know what they might be doing to counteract that if they are not as fortunate with their ability
Yeah.
to design the supply chain?
Um, I can't say that I recall talking about temperature with these batteries. Was your is your client um, is it lithium ion that they're working with, or is it a different type of battery?
Um, I believe they were lithium ion. They were getting them from Johnson Controls,
Oh, okay,
actually.
interesting.
Hmm.
Yeah, they would probably be lithium ion then. Yeah,
Hmm.
that hasn't come across my plate actually, unfortunately. Um, but we also were dealing with what's called lithium iron phosphate LFP batteries, which are a form
Hmm.
of lithium ion, and they're a little bit more robust. They can handle sort of temperature cycling a little bit better than some of the really high energy density batteries.
Okay, that makes sense. This manufacturer, they were shipping across the country, so
Okay, yeah.
that
So
would that would
yeah,
make
definitely
sense.
you're getting into the you know near 200 degrees probably sometimes in trucks.
Hmm. Hmm. And the cold temperatures as well. So they were going
Sure.
from a cold environment to a hot environment. So that
Yeah.
would make sense. Okay, so
Hmm.
what else can you tell me that is unique about, say, EV packaging Tesla? I know Tesla
Yeah.
does things differently than most automotive manufacturers. So
Yeah.
curious to hear about that.
So I was sort of talking about how like where you locate the battery manufacturing makes a big difference, obviously, from a supply chain standpoint. So Tesla started out with a separate building, a separate facility that was producing the batteries and like the packs, and then we would ship those packs in. One of the interesting parts about that is the packs are so heavy. It's a large part of the weight of the vehicle is just in the battery itself. They're over 1,000 pounds each typically, and so you run into this problem where if you are going to transport it over the road, it's weighing out the truck very quickly.
Hmm.
So
Hmm.
44,000 pounds is kind of the standard for weight limits for trucking, for a 53 footer. And so what we ended up doing in some cases was we opted to actually ship them in aluminum racks, which are big metal racks. You put one battery in it, and that
Hmm.
actually would go into an automation cell. But we opted for aluminum because the weight savings from compared to steel got us another, let's say, 3 batteries per truck. And so
Hmm.
when you're talking about going from 20 to 23, that's a pretty big difference. That's 10-15% difference in freight efficiency. And so that was worth the extraordinary cost of going with an all aluminum rack, which typically you would never do, just from a cost standpoint.
Hmm.
So then you fast forward to the facility that was built down in Texas, and everything's just on site. So the batteries are being built up on the 4th floor, and then they take a conveyor down to the 1st floor and go right into the car. So
That's
you
the one
just
right
kind of
outside of Austin.
yep, exactly. Austin Gigafactory. So you're taking that whole supply chain out of it now. It's just raw material kind of coming in, and then finished car coming out the other side. Um, and so the big challenge there was then all the conveyance and how you design things like, actually, I've got a little sample here.
This is why
There's
we're
like,
friends, just so everyone knows, because
yeah,
we
got
both have
stuff everywhere.
trinkets. Hmm.
Yeah. Yeah. So things like this, which are designed for like automation cells for battery cells, you can put them, this is a very consistent, like geometrically consistent shape. It's very modular. And so you can just kind of like pop these things in and out if they get damaged. And so, yeah, that was kind of like the other piece is just like the automation side of things. I would say that EVs are much more automatable because you don't have the super, super complex engine and all those components and all the sort of steel that goes into that. It's much more automatable. So Tesla was, you know, trying to lead the way in automation, and that creates tons of challenges on the packaging side because now all of a sudden everything is not being manually grabbed, and so it changed the problem from ergonomics to geometric and how robots can get in and pick parts and yeah, created tons of challenges on that front.
Yeah, that's interesting. Yeah. So you're going to have to worry about making sure that your trays or your packs have locator pins so that the robot
Yes.
can identify a point, a perspective, and they can be programmed to move the parts and pieces that are in the
Yeah.
packet in and out based on that.
Ye- Yeah, there's sort of like there's what you might call dumb automation, and then there's smart automation. Dumb
Mhm.
automation would be I'm a robot and I just expect a part to be in space in a certain spot. And so I'm just going to reach for that, and I have no way of knowing whether something has fallen or things are not in the right place. I'm just going to go and reach for it, and if it's not there or if things are kind of off, then the robot crashes. I would consider that like dumb automation.
Mhm.
Sometimes they have vision built in, but that tends to slow down the robotic picking ability. And so if you want to go really quick, the processing power isn't really there on board for most of these robots to have the vision. So it needs to be like, physically, geometrically very consistent. So that's tough.
Mhm. Okay, I want to back up a little bit.
Sure.
When you talk about battery packs,
Sure.
people that are outside of packaging consider the battery pack. They'll refer to it as packaging, but I would say it's more like a cover or a case. Can you kind of explain that a little bit so that the students can differentiate when they hear it?
Sure. Yeah. Um, so the kind of the structure of a battery pack is the cells are placed into or in between um, cooling cooling lines. So there are these flat kind of wavy cooling lines that snake between all the batteries, and that is how they cool the batteries and or warm them if it's really cold out. Um, and so you've got sort of these rows of battery cooling line, and a lot of times those are put into a big metal structure, aluminum or steel, that is essentially like just a couple of flat sheets with I-beams running down through it. Um, and that whole thing is then like gasketed and sealed off. And sometimes they even put like what's called like potting material. So it's like they'll actually like pot the batteries in there with like an epoxy or something like that. And so that everything is like very structurally sound, very, very rigid. Um, and that actually gives a lot of structural strength to the car itself. Um, and so, yeah, that's kind of like the general structure of a battery pack.
Okay, great. So basically, I worked in an engine plant years ago.
Okay.
So it sounds like the EV pack is equivalent to what would be the engine, and they don't call it a pack, but the engine is
Yes.
sealed with a gasket and everything's internal, but then that still has to go on a rack and get shipped.
Yeah, it's definitely part of like what you would think of as like the powertrain in like an old traditional internal combustion engine vehicles. So it would be the battery pack and then obviously the electric motors. But most of those are much simpler in general than
Mhm.
the amount of components that need to go into an engine. So it can pretty much be made in like a single cell, like a robotic cell will kind of put all the wiring and everything and kind of assemble it, and then you just output a full motor. So it's definitely much simpler than
Okay.
the yeah an ICE
Okay.
vehicle.
Well, thank you. Yeah, I wanted to make sure that you define that because in some of these, if they work in automotive and it's not whether it's EV or not, there sometimes people will ask them to work on the design of a
Hmm.
pack, and it could be something like a battery pack. So they need to be
Yeah,
aware. So if someone says, "Oh, we need you to work on a battery pack," well, actually, those are going to be your design engineers that work on the part because that's considered a part.
right,
So I just want
exactly.
to make sure that they are aware of that.
Yeah,
Um,
that's definitely.
mhm. what else? Is there anything else that you'd like to bring up about EV packaging? Because I know I also wanted to touch base on, your
Yeah.
software.
Yes, specific to EV packaging, if what we ended up going to over the road is actually, so the aluminum rack was sort of like the first iteration, and then the second iteration was plastic. So we actually went with thermoformed trays for the batteries, and there's these type of trays called twin sheet thermoform trays, which are more rigid. They just have two pieces to them, and they are layered on top of each other and welded together. So basically it's a twin sheet thermoform tray that holds these batteries with some structural beams that are put through it, and so we actually were able to lightweight the pack even more, ship even more per truck. So I just wanted to call that out.
Okay, that's
It's
great.
always it's ongoing. This is a definitely automotive packaging in general. I would say is a little bit stagnant in that things are kind of done the same way. And I mean, even like robotic welding has been around for years and years and years,
Hmm.
since like the 80s. So in some ways, it's pretty stagnant. But I think with the EV revolution or whatever we want to call it, it's sort of presenting some opportunities to innovate a little bit, which is good.
Hmm. Yeah, that's good to hear. Um, I'm trying to think if there's anything else I wanted to ask you. I think that's really it. This was
Okay.
really good to give the students an idea of some of the differences between the EV packaging and traditional motor,
Yeah.
engine packaging. Okay, so I guess the last thing I want to ask you about is you mentioned that you went from an aluminum rack to a plastic rack. Now, a lot of people, when it comes to sustainability, they try to avoid plastic.
Yeah.
And, EVs are considered to be more sustainable in general. So,
Hmm.
how did you all justify that?
So, it's being utilized for 4 years. These are obviously all reusable packaging.
Hmm.
So nothing is getting thrown out. And from that perspective, when you get, hundreds of uses out of these things, then the carbon footprint or the impact is much, much lower than anything else you. So even if you, let's say it's, steel is half the environmental impact to plastic, well, at over 100 uses, that difference is negligible. So
Hmm.
and then you've got the freight savings or the cost of sorry, the carbon from like the actual transportation. If you get another 4 packs per truck, then that eliminates, some hundreds of trucks per year that just don't have to make the trip. So
Yeah, that makes sense. Thank you. Okay, well,
sure.
let's shift gears a little bit and talk
Sure.
about the software that you have developed with your consulting business.
Yeah. Thanks. Yeah, it's going to be very quick, but essentially, in automotive packaging, it's different from sort of consumer goods in that, like, you pack in bulk, and it's the same exact part, sort of iterated over, or sort of tessellated over, I guess is the better term, over different types of packaging, whether it's bulk packaging, literal, like large bins, big racks, or even small expendable corrugated boxes. And so when you're doing is you often will know or have like the 3D CAD for these parts years in advance of ever seeing them in person. And so the planning stages happen for 2 to 3 years, I would say, um, to plan for the actual production of these vehicles. And so um, it became necessary to really be able to like show and see how these parts lay out in space. And so I worked with a company called Inkbit to develop this um, software, and I'm going to go ahead and share
Okay,
my screen now.
it should be working.
Okay.
Is it working?
Yes.
Okay, great. Okay, perfect.
Awesome. So I'm going to go ahead and just start a brand new one here. Let's say here's my part. This is a little trim bezel. And it's just a little piece of plastic, but we need to know how efficiently we can pack this. And so we can plan for how much warehousing do we need for it, what kind of line side space do we need. And so I've got a bunch of sort of standard Toyota bins here. And I'm going to go ahead and just run this with different packing methods, different compartment shapes. I have a bunch of standard orientations that are computed automatically by the system when you first load the part in. I can create some corrugated separation if I want, different flutings, and then part margin, sort of distance or comparison between the parts, distance between the parts, excuse me. You can add in weight, delivery distance, some of the costs, and then average humidity and things like that. One thing I'm going to add here is actually I'm going to add some corrugated boxes in here. So what this is going to do is actually automatically compute the McKee formula for you, and then adjusting the humidity will allow you to see what that looks like. And then you can also adjust the ergonomics. So let's say you want it to be a maximum 33-pound weight limit for handheld containers, which is an OSHA sort of requirement these days. You have to make sure that you limit the amount that the weight that people are carrying. I'll disable it for now, but let's go ahead and run this and sort of see how it packs out. So the best option here is this large 48 by 45 by 32 box. And this is how it would pack out if you were to put sort of different separators in there. I could also run this as a planar layering. So if I run it again, then I've got just the corrugated sort of slip sheets in between. You can also run it without those. Or I have the option of doing things like bulk layer or bulk packing it. So I can see if these parts were just sort of cascaded in a non rigid way, then I can see how many would fit. And so, yeah, that's the basics of the software. Once it's done running this, it will actually analyze the cost of everything. So that's both packaging and logistics costs, and rank them from best to worst. Best to worst. Yeah.
This is wonderful. So you all, whoever's watching this, the students that are watching this, this reaches back to the homework that you had, where you had to calculate this by hand in different orientations for the radios. So
Yep.
this is exactly the same assignment, except it's software based. So there are a couple things that, you'll see. And again, Scott mentioned that you'll have to figure out what type of packaging you need early on in the program, before you even have the parts, before the parts are even sourced or they have a supplier for them, because you'll need to build a budget for what kind of material you need. If you're going to be using any sort of racks or anything returnable, you have to let the program know how much money you're going to need ahead of time.
Yeah, and in fact, this will inform where you should locate parts. A lot of times there's this sort of push and pull that happens with the procurement team that says, I can buy this for 10 cents, locally, or I can buy it for 9 cents in China. And so they say, I'm going for the 9 cents. That saves me 1 cent per part. That's, $100,000 in savings per year. But what they fail to realize is now you went from what could be a returnable pack to an expendable pack, and it adds 20 cents of cost. Literally, sometimes I've seen doubling of the actual part cost just in the packaging, and let alone the freight. So yeah, that actually, the more accurate you can get this information up front to the procurement team, the better kind of decision making they can do. So that was the impetus for this.
Yes. So yeah, this touched on 2 or 3 different homework assignments that you worked on this semester. So now you can visualize why you were learning that. So
yep.
And then Scott.
Absolutely. I just wanted to call out that it also will show the sort of truck loading as well, to make sure that it's optimizing for that. And you can generate a report that shows all the different information here and the costing. So yeah,
that was part of your first homework assignment, where you had to figure out how many trucks were coming in per day and figuring out how much fits on a truck.
And that's still done manually across the industry. So that's kind of one of the reasons I wanted to build this too.
Yes. We've cried over it all the time over this stuff, when you have something that needs to be rushed out and figure out what the best thing is. So wonderful. Well, thank you, Scott. I appreciate you. This is wonderful. I will publish this, and the students will have this to look at. And I know I was talking extra credit, but this might actually be part of the last assignment.
Perfect. Sounds great. Well, thank you. Thank
Okay.
you
Thank you,
for
Scott.
talking. All right.
Yep.
Have a good day.
Always great to talk
Bye.
to you. Bye bye.